Hello. Today, let me discuss a problem in Fourier series. First of all, let me explain what is the meaning of a Fourier series. So, given a function f of x defined in the interval, let us say that this has been defined in the interval 0 to 2 pi. Such a function f of x is any function given, and it is defined in the interval 0 to 2 pi. If such a function can be expressed as a series in terms of sine and cos, then such a series will be called as a Fourier series. Fourier series is a name given because it was the series which was given by Fourier, a great mathematician. So this Fourier series is nothing but the expressing a given function which is defined in an interval in terms of sine and cos. A series in terms of sine and cos. But whether we should ask a question whether any function can be expressed in terms of sine and cos as a series. A function can be expressed as a series in sine and cosine only when it satisfies the conditions of Dirichlet. In the sense, Dirichlet conditions are there. D-I-R-I-C-H-L-E-T. So Dirichlet conditions are the conditions which are to be satisfied by a function f of x to be expressible as a series in sine and cos. The conditions required are f of x should be a periodic function in the sense that it must periodically occur for a particular period in the period. For example, here it is given 0 to 2 pi. Let us suppose that this function takes a form like this. Then you see that this 0 to 2 pi, 4 pi, the 0 to 2 pi, it takes a function, the function takes a form of this and it gets repeated for every interval of 2 pi. Can you catch my point? So, if a function repeats for every interval of 2 pi or whatever be given, you see that such a function will be called as a periodic function. In general, how we define is f of x plus p is equal to f of x, and this p is a list, and even you can put plus or minus, nothing wrong in that. See, it gets, for example, you see that sine x. See, this sine x is a function which gets repeated for what? Every 2 pi value, so that is 2 pi x. See, I will put like this, 2n pi is equal to sine x. So x plus 2n pi for any value that give for this positive integer, let us suppose it's positive integer. So you see that cos x plus 2n pi will be equal to sine x, and this is with actually it is so, but I can write this as sine of x plus 2 pi is equal to sine x, and you see that this 2 pi is the least number for which the sine function gets repeated. Therefore, the period of this sine function is 2 pi. Can you catch? Yeah, another example is that you see that if today is Monday, say for every 7 days, this even after 14 days you will get Monday, even after 21 days you will get Monday, but the least number for which it can repeat is 7 days. Those 7 days is called the period of the week. Can you understand? So you see that same way here it is called a period. That means that function gets repeated for every that here it in the case of sine means it is 2 pi. For every 2 pi you see that the sine function gets repeated. So that is so for 2 pi is called the period of the function. So you see that this must be f of x must be a periodic function. Number 2, it must be single valued function. Number 3, it must have finite number of maxima, minima in the interval defined. If it is defined in the interval, it must have finite number of maxima, minima and finite number of discontinuities. It can see you can have discontinuities. You see that it will be like this, it will be like this. So it can have discontinuities in between, and the number of discontinuities must be finite. So the four conditions here that ought to be satisfied by a function f of x to be expressible as a series in sine and cos are that it must be a periodic function, and number 2, it must be single valued function. Number 3, it must have finite number of maxima, minima in the interval it is defined, and also must have finite number of discontinuities in the interval it is defined. So such a function can be expressed as a what? A Fourier series. Now, with a small background, the preliminaries, let me explain a problem in Fourier series. I will take up a problem and see how that is expressible as a series in sine and cos. See, here let me write this. See, I will obtain, see, this is the problem. Obtain the Fourier series for f of x is equal to e to the power of minus x 0 less than x less than 2 pi. So this is what is given to you. Now you are going to express this e to the power of minus x as a Fourier series. So the step 1, what is that you must do is, see, I will write step 1. See, if you go by, see, a flow chart, like if you start writing step by step doing, you see that everything, it must be rhythmic form. It must be just like writing a poetry, that you go by step so that you will arrive at the answer without any difficulty, or systematic approach is required. So you see that step 1 is write, see what is that? Write the Fourier series for any function. See, what is the Fourier series for any function? It is f of x is equal to a0 by 2 plus sigma of 1 to infinity an cos nx plus it is 1 to infinity of bn sin nx. Sin nx. And this a0, b0 are called the Fourier coefficients or Euler coefficients, and this is given by, it is 1 by pi, 0 to 2 pi into, it is f of x dx, and this an is equal to 1 by pi, 0 to 2 pi f of x into cos nx dx, and your bn is equal to 1 by pi 0 to 2 pi f of x into sin nx dx. So call this as your 1. Now you see that this is your Fourier series. This I will call it as 2, and I will call this as my 1. So you see that your Fourier series is given like this: f of x is equal to a0 by 2 sigma 1 to infinity of an cos nx, and this is bn sin nx. This a0, an, bn are called the Fourier coefficients. They are called the Fourier coefficients. They are called the Fourier coefficients, whose values are given by a0 is equal to 1 by pi 0 to 2 pi f of x dx, like that I have given. Now find the values of all this, substitute here and get the Fourier series for the function e to the power of minus x. So that's all we are going to do. For this you must have certain background, that is prior knowledge is required for arriving at the answer. So what are those things that are? See, I will write here. See, let me start doing this. As and when I come to this situation, I will explain whatever that are required to get the answer, that is to do the problem. What are the things that are required to do the problem, that will be explained as and when I come to the situation. Okay, now you see that, let me take this. Now let me start doing this. Now what's your a naught? A naught is equal to 1 by pi 0 to 2 pi. What is your f of x? F of x is e to the power of minus x into dx. So this integration is very simple. E to the power of minus x divided by minus 1, and you have got here 1 by pi, it is 0 to 2 pi. So this is, take this minus 7 outside, it is e to the power of minus x is e to the first limit, then minus e to the power of 0 is 1. So this is equal to 1 minus e to the power of minus 2 pi divided by pi. So we have got the first coefficient a naught, namely I will write it here. A naught is equal to 1 by pi within brackets 1 minus e to the power of minus 2 pi. So let me keep this. So this is one number. First result we have got this. Then we will start doing the an. Now I will write here an now, so that you will understand better. So I will do this. What is your an? An is equal to 1 by pi 0 to 2 pi. It is e to the power of minus x cos nx dx. Now you see that this is this requires a knowledge of this integration, requires a knowledge of the integral. See, we know that integral of e to the power of ax cos bx dx is equal to, I will write something here, you try to understand how I do this. It is the real part of, I will write here real part of, it is e to the power of ax into e to the power of I bx dx. Now you see that using de Moivre's theorem, you can write this e to the power of I bx as cos bx plus I sin bx. If we take the real part, it is e to the power of ax into cos bx. So there is no harm in writing like this. Now the next thing that you can write this is, it is integral of e to the power of x into a plus ib into dx. So you take this x outside, so you will get a plus ib. Now what is this equal to? This is equal to, integration is very simple, that you will get e to the power of x into a plus ib divided by a plus ib. So this can be written as, see, e to the power of ax divided by a plus ib into e to the power of ibx. Yes. Now what is this equal to? So this will be equal to, I will write this as 1 by a minus ib multiplied by a minus ib. I multiply the numerator and denominator by the conjugate, so you get this. So what is that you get here now? It is e to the power of ax into, expand this, this is nothing but using de Moivre's theorem, cos bx plus I sin bx. So this is equal to, see here already that a plus ib is here. So you multiply this a minus ib into a plus ib is a square plus b square. So what is that you get? E to the power of ax into a minus ib divided by a squared plus b squared into, you will get this as, what is that you get here? Cos bx plus I sin bx. Now take this a inside, so you'll get this as a to the power of ax into a squared plus b squared in the denominator. Take this inside, so it is a cos bx minus I into plus I will be what? Plus 1. So b sin bx plus I into, say I will take here, I into a sin bx minus b cos bx. So this is what I get. So you see that I get, using this idea of this e to the power of ax can be written as a real part and then this. So when you do this, now I have done the full integration here. If you take the real, see, understand that here everywhere you must take this real part, here also real part, here also real part, and here again real part, and here again real part. So what is that you will get here? So in general from this you will get here, it is e to the power of ax cos bx dx will be equal to, equate the real part, it is e to the power of ax divided by a squared plus b squared into a cos bx, and plus b sin bx, So you see that I am getting, suppose if you want this, you want e to the power of sin ax sin bx dx, it will be nothing but what? The imaginary part. If you want, that is, I will write here. Similarly, what is that you can find here? E to the power of ax sin bx. Now for sin bx you will get what? Imaginary part. So what is your imaginary part here? E to the power of ax divided by a squared plus b squared. Write those terms, a sin bx minus b cos bx. So you see that I am able to get these two results here. So now you see that this is of the same form, e to the power of minus x. In the place of a you have got minus 1, and in the place of b you have got n. So this is, you see that in this particular problem you have got, this is similar to this. Now I have to use this formula in order to arrive at the integral value. So this you must necessarily remember, not only for this problem, but this will come in very many number of problems, and this has to be either you remember it or derive it in this way and keep it in your mind. Once you derive, everything will come to your mind, that is, it will stick to your mind, that you can write from your memory. So this is what I will get. So I will, now it is easy for me to write everything. Once this is done means what? It is easy for you to write. Now let me write this. Now what is that you will write here? So in this place, so let me write here. So this is equal to, this is equal to, now you see that this 1 by pi is here, into, in the place of a you have got minus 1, see, minus 1, and in the place of b you have got what? N. So what is that you will write here? It is e to the power of ax. So e to the power of ax means what? E to the power of minus x divided by a squared plus b squared. A squared is what? It is minus 1. It is minus 1 squared plus n squared, that is 1 squared plus n squared. And inside the bracket, what is that you have got here? A cos bx. What is your a? It is minus 1 into cos nx, and then plus b sin nx, that is plus b sin nx, and everything has to be raised to limits to pi. So this is what you will get. Now you substitute the values. What is that you will get? Here you see that 1 by pi into 1 plus n squared within brackets. So first apply the first limit, upper limit, e to the power of minus 2 pi into within brackets. If you apply this 2 pi n, you must know that it becomes cos 2. See here minus 1 is here, so it is minus cos 2 pi n. See 2 pi n. In the place of x you put 2 pi. So it is minus 2 cos n pi n plus n. In the place of say this one sine 2 pi n. Okay. Then minus e to the power of 0 because you are applying the second limit, e to the power of 0 into minus cos 0 plus n sine 0. So this also. So I have applied the limits, that is upper limit is 2 pi and the lower limit is 0. So you will get this. Now this is equal to 1 by pi into 1 plus n squared. Now you see that e to the power of minus 2 pi within brackets. Now what is your cos 2n pi? You must know that cos of, see it is like this, cos pi is equal to minus 1 to the power of n pi. I'll write here cos n pi is equal to minus 1 to the power of n. You give n is equal to 1, it is minus 1. Give n is equal to 2, it is plus 1. Give n is, so for odd values it will take minus 1. For even values it will take plus 1. So you see that this cos 2n pi, if you are going to substitute n is equal to 1, 2, 3, whatever number values that you are going to assign, it is going to be an even number, that it remain as plus 1 only. So what is that you will get? So this is plus 1. So it is minus 1. Okay. This is plus 1. This is 1. So it is minus 1. And this one cos 2n pi is 0. Cos 2n pi is equal to 0 for cos 2n pi in general it is equal to 0 for all values f n, and sine cos 2n pi is equal to 1 for all. See, cos 2n pi is equal to 1 for all n, for all n, and here again no, for all n. For sine 2n pi is equal to 0 for all n, and cos 2n pi is equal to 1 for all n. Whereas cos n pi is equal to minus 1 to the power of n, it will take alternately minus plus minus plus. If it is odd multiple it will minus, if it is even multiple it is plus. So you see that these are the things that you must know. So applying those ideas here, what is that you get here now? So this is my e to the power of minus 2 pi into minus 1, and this is 0. This is value of this is 0. Okay, minus e to the power of 0 is 1 and cos 0 is 1. Cos 0 is 1. Cos 0 degrees is 1. So this is equal to what? 1 into minus 1. So what is that you will get here? So this is equal to 1 by pi into 1 plus n square into, see minus into minus is plus, and this is minus 1 minus e to the power of minus 2 pi. So this is what you get. So this is your value for what? This is your an. So this is your an. So what is your an now? An is equal to 1 by pi into 1 plus n square into 1 minus e to the power of 2 pi. So an has been got, a naught has been got, and an has been got. Now let us find the value of bn. So I hope that you are able to understand. I go slowly in order to make you understand. And if those students who are either doing engineering mathematics or even in arts and science, BSc mathematics or BSc computer science, you will find my teaching will help you a lot to understand the problem. Follow me carefully, and if you have any comments with regard to my teaching or explanation, you can very well write your comments. It will be seen and due action will be taken. Don't worry about that. Now, so you see that this is what we get. Now let me come to Bn. So what is your Bn now? What is your Bn? Bn is equal to 1 by pi 0 to 2 pi, it is e to the power of minus x into sine nx dx. So this is equal to what? Already we have told you, in the place of n you have got a, you have got minus 1. In the place of b you have got what? N. So what is this? We have written here. So it is e to the power of ax. So e to the power of ax means what? E to the power of minus. It is e to the power of, yes, e to the power of minus x divided by, this 1 by pi is already there. 1 by pi is very much there. So it is 1 by pi e to the power of minus x divided by 1 plus n square. Then a sin bx, what is your a? Minus 1. Sin bx is sin x, because in the place of b you have got sin nx. And this one, it is plus, it is minus b cos, what is in the place of b? N. N cos nx. This one, this must be raised to limits 0 to 2 pi. This must be raised to limits 0 to 2 pi. Now as before, take this outside, 1 by pi into 1 plus n squared, and within brackets apply the first limit here, e to the power of minus 2 pi within brackets. Now you write this minus sine 2n pi, because in the place of x you put 2 pi. So minus 2 pi minus pi minus, it is a minus n, it is not pi, it is minus n. Minus n into cos 2n pi. In the place of x you put 2 pi. So this is what you will get. Minus, second limit is e to the power of 0. Then you see that this is minus sine 0 minus n cos 0. So I have applied the limits. In the first limit, it is the upper limit is 2 pi and the lower limit is 0. So this is what you will get. So what is that you get here? 1 plus pi into 1 plus n squared e to the power, say whatever you get, you write. So what is this? E to the power of minus 2 pi. And within brackets, see sin 2n pi I have shown here. See sin 2n pi is equal to 0 for all values. So this is 0. And sin 2n cos 2n pi is equal to 1. This is also I again you. So it is minus n. So it is minus n minus e to the power of 0 is 1 and sin 0 is 0, and this is what? It is cos 0 is 1, so it is minus n. So this is what you get. So what is that you get now here now? So 1 plus pi into 1 plus n squared, inside the bracket it is minus n into e to the power of minus 2 pi. Minus into minus will make it as plus, and it is n. And so you take that n outside, so it will be giving you the answer n divided by pi into 1 plus n squared into within brackets 1 minus e to the power of minus 2 pi. So this is your Bn. So you see that I am able to get Bn also. What is my Bn? Bn is equal to n divided by pi into 1 plus n squared into 1 minus e to the power of minus 2 pi. So I am able to get the Fourier coefficients. Fourier coefficients a0, an and bn, and this formula is very, very important. Now let me give you the Fourier series. That means I can give that. Now let us write the Fourier series. Now the Fourier series is given by the Fourier series. Now using what? See, using 1, that's all. Now the Fourier series is Now the Fourier series for f of x is equal to minus x, 0 less than x less than 2 pi is this one, that is using 2, using 1, f of x is equal to e to the power of minus x is equal to a naught by 2. What is your a naught by 2? A naught I have got here. So 1 by 2 pi into 1 minus e to the power of minus 2 pi. 1 by c, half of a naught plus 1 to infinity. It is a n, see, cos nx. What is your this one? 1 by pi into 1 plus n square into, what is that you get? 1 minus e to the power of minus 2 pi into cos nx plus 1 to infinity n divided by pi into 1 plus n square 1 minus e to the power of 2 pi into sin nx. So I am writing the coefficients. See, the Fourier coefficients an and bn in the respective places. Now this is equal to, so e to the power of minus x. See, here you can find this, pi can be 1 by pi can be taken outside and this one can be taken outside, and you cannot take this n and everything because n is the summation. See, n is running over, n takes the values from 1 to infinity, it has to be in the summation. So you cannot pull those things outside. You can take this 1 minus e to the power of minus 2 pi because it does not involve any n. So you can pull them out and you can take this pi out and you can take here 1 by pi. So you see that what is that you will get here? So inside the bracket half. See, half into this will give you this plus it is 1 to infinity, it is 1 by 1 plus n square into cos nx. You write the balance of it. So plus it is nothing but 1 to infinity n divided by 1 plus n square into sin nx. So this is my series, Fourier series. Now you cannot just leave it like this, at least write 2 or 3 terms here so that it will be fine to look at. So this is equal to, so this is 1 minus e to the power of 2 pi divided by pi into within brackets half plus, put n is equal to 1. So if you put n is equal to 1, what is that you will get here? It is 1 by 2 plus 1 by 2 cos x plus, if you put n is equal to 2, 1 by 5 cos 2x plus, put 3 here, 3 3s are 9, what is 1 by 10 so this is what you get. Plus, what is this now you will get for this? It is 1, see, 1, put n is equal to 1 here, 1 by 1, 2, 1 by 2 sin x plus 2 by 5 sin 2x plus 3 by 10 sin 3x. So this is what you get, and because this bracket, this is 1 minus e to the power of 2 by pi, it has to multiply all the terms inside. So you see that this is half, plus you expand this, give at least 3 terms here, 3 terms here. So you see that this is the Fourier series of the given function f of x is equal to e to the power of minus x. That means what, within that you will have this series. Now you can find the value of this e to the power of minus x at each and every point. You just Fourier this thing, you substitute x is equal to give a value, you will get the what, the corresponding values you will get, and you can this thing. And know that there can also be discontinuities, as I told you. It can have discontinuities in the interval defined, in which case sometimes you may be asked to find the value of the function, to what value it converges at the point of discontinuity. So such problems will be taught in the coming classes. So I will take more number of problems in the coming days to make you better or equip you better in this Fourier series. Thank you.